Alright class, welcome back. It's Piecewise Functions Day 2. We're pretty much doing the same thing today except for I'm asking a little bit more. You have to list the intercepts, find the domain and range, which you guys already know how to do, so we're really just putting it together. So again, like I said on the last video, to draw these things, what I like to do is just plot the dots of this whole equation first. So I'll do this one in red. And this states that you start at a y-intercept of 3 at y. So I'm going to start there. And this has a -1 slope, so that would be going this way and going this way. Now, you can kind of get a hint based on where the information is. We only want dots that start at -5 for the x, so that would be this dot, and it's filled in. And then we want everything to go to the left, so that's this way. So that's all I want. So pretty much I want to erase all those other dots now, because I'm not using them. And now I'm going to graph this line, 2x plus 1. So I start at the plus 1, and then I do 2x, so up 2 over 1. So going that way it looks like this, and going this way it looks like this. Now, you should note that, I'm going to make sure I did that right. Yep, that one there. And then you want to make sure that when you get to -5, that's the one we're going to start at, because it says -5 and bigger. So I'm going to put an open circle here because I'm at -5, and then it's everything to the right. So it's this whole line here. Now, our intercepts. We have two intercepts. We have the y-intercept, which we know is based on this blue equation. So the y-intercept is the point 0, 1. We don't know what the x-intercept is, though, because it's kind of ambiguous. It's right here. However, we're still on the blue line. So to find the x-intercept, we make y 0. So we set it equal to 0. 0 equals 2x plus 1. -1 equals 2x. X equals -1/2, which makes sense, because if it's going down 2 and 1, it'll cross at -1/2. So the x-intercept is -1/2, 0. Since this is connected, if you notice, this is filled in even though this is open, there's still a point at -5. You would agree that all x values are accounted for here, because this is going off to the right and left. So for part B, the domain is just -infinity to infinity. You have to be careful about the range, though. This graph goes up forever, so the top part will be infinity. However, it starts down here. The lowest point of the graph is at -9, and since it's not filled in, it's an open bracket. So again, you look for the lowest to the highest for range, left to right for domain. Good. So that's that problem. Let's do it again. We have 3 equations here. First off, we have this one, x, when x is greater than 0, or less than 0, I should say. I said that wrong. So if y equals x, this is the starting point, and then it does this. That's that line. Okay, so it says it starts at 0 and is open, so actually I should probably erase that dot and make it an open dot right there at the 0. And then we want everything to the left of 0, so that's this line, this part of the line. Usually it's written in that order, so you could assume that the first one's going to go to the left. Then it says at 0, I'll put this in green, when x equals 0, there's a point at 5, y equals 5, so I'm going to just put a dot there. Okay, and then we have this other line that starts at -1, and again it's going to be an open circle, and then it goes down -3 and over, well, down 3 and over 1, down 3 and over 1, down 3 and over 1. And since it is to the right, we want this side. We don't have to go that way because we're going into that other section, which we don't want. There we go. So that is my graph. Again, if you look from left to right, we can go all the way to the left. At 0, there is a dot, so it is still part of the domain, and then to the right. So I kind of skipped the intercepts. I'll do that in a second. I was talking about domain there. The domain is still negative infinity to infinity. The intercepts. If you look carefully, there are no x-intercepts. And then if you look carefully again, there is a y-intercept, but it's really where the dot is. So the y-intercept for this function is at 0, 5. Not here or here, because those are open. Now we look at the range. Well, you would agree that the range goes from negative infinity, because it's all the way down, and then you get up to 0, the line y equals 0, because of this red line. It doesn't matter that that's open. So from negative infinity to 0, and we also have to include y equals 5, because that is part of the range. That's an output, y being 5. That's a weird one, I know, because there's a random point up there, but it is what you would do. Okay. So that's that one. This is a little bit more tricky, but, well, I don't know if it really is. We'll see. First thing you got to do is figure out your slope and your y-intercept for this line. So I would agree that my slope is 1, 2, 3, 1, 2. So up 3 over 2. So this has a slope of 3/2. 1, 2. So the problem is I don't know where the y-intercept is. So we're going to have to use point-slope form to get an equation for this line. I'm going to use this point over here, 1, 2, 3, negative 3, 0, and that slope to find my equation. So if you guys remember correctly, I know I gave you point-slope form from your Unit 0 packet. It's y minus the y-coordinate equals the slope times x minus, which becomes a plus, the x-coordinate. So we get y is equal to 3/2 x plus 9/2. That's the equation of, excuse me, of this line, right there. So we know that equation. You should know the equation of this line over here, because it's a horizontal line at -1. So we'd say y equals -1. So now all we have to do is put it together. To write an equation of a piecewise, we have f of x equals, and then we have the bracket. So the left piece is this 3/2 x plus 9/2. And now you just have to say what x goes to. X starts at -1 and goes to the left, but it does not include it because it's open. So you just say it's less than -1. Then we go to the other equation, which I did in red. This is f of x equals, and we just put a -1. You do not need to put y's here and here. This is your y, okay? And it's just saying y equals this function here and this function for this domain. So this domain starts at -1 and it goes to the right. Notice how if you put the x on the left, the arrow points in the direction, the inequality symbol points in the direction of the line. So this one points to the left, so it's the left one. This one points to the right, it's the right one. And that goes off forever. So that's it. We've just created our piecewise function. All you have to do is get the individual equations of the two lines, figure out where they split, so you can write your domain restrictions on the side, and put it together in this nice little bracket form. Alright, so that was Piecewise Day 2. More of the same with a little bit of twist on it. I'll see you guys later.